earliest and most far-off universe, seen at the time its revelation, given a basic window into the states of the early universe and the development of the primary worlds, the splendor of CS 1019 regardless of its outrageous distance makes it a brilliant focus for additional review worlds like CS 109 stand apart due to their somewhat high radiance, which implies they discharge more light than different cosmic systems. From a similar period, this splendor permits stargazers to study their properties more meticulously, even with the difficulties presented by their tremendous distances and the red moving of their light. The recognizable proof of CS 1019 was a critical achievement in observational cosmology. It assisted space experts with pushing the limits of how we might interpret the early universe, uncovering that worlds had proactively framed and developed to a extensive degree only 200 or 300 million years after the enormous detonation. This disclosure additionally featured the potential of utilizing progressed telescopes like Hubble to investigate the far-off ranges of the universe, preparing for considerably more definite perceptions with next-age instruments like the James Webb Space Telescope (JWST). The Hubble Space Telescope's capacities permitted stargazers to affirm the presence of CS 1019 and comparative universes, yet the definite investigation of these items remained tricky. The earliest light in the universe is redshifted to such an extent that just a strong committed infrared instrument like JWST can test it. Actually, JWST, sent off in December 2021, is explicitly intended to notice the infrared piece of the range, making it an optimal device for concentrating on the epoch of reionization and the early universe. When JWST started its central goal, CS 1019, the most brilliant of the Hubble systems from this epoch, was a conspicuous objective for its instruments. The telescope noticed the cosmic system for only 1 hour, yet the information it returned was extraordinarily rich. JW's high-level sensors caught a definite range of the world, giving cosmologists with exceptional data about its piece construction and star-shaping exercises. This abundance of information uncovered new subtleties about CS 1019 and other early worlds, offering experiences into their development. Furthermore, advancement during the universe's in examining the JWST information, space experts found that CS 1019 showed both the light from star development and a wide discharge highlight ordinarily related with dynamic cosmic cores. A.g. this double discharge was unforeseen, as cosmic systems in the early universe as a rule produce either light from A.g. or light from star arrangement, yet not both. At the same time, the presence of both kinds of discharge in CS 1019 recommends that the system harbors a very enormous dark opening that is effectively developing by accumulating matter. This finding has critical ramifications for our comprehension of the early universe. It demonstrates that very huge dark openings could frame and become quickly, even in the initial not many 100 million years later. The enormous detonation, the revelation of such a dark opening in CS 1019 difficulties existing speculations about the arrangement, also development of dark openings and systems in the early universe. It recommends that these cycles might be more perplexing and entwined than recently suspected. Moreover, the nitty-gritty investigation of CS 1019 and comparable universes can help stargazers piece together the course of events of the epoch of reionization by looking at the light from these universes. Scientists can derive the territory of the intergalactic medium at various times. What's more, decide when and how the reionization process happened. This data is vital for building a thorough image of the universe's early history and the arrangement of its first designs, the disclosure of CS 1019 and its resulting concentrate on utilizing JWST. Under highlight the significance of high-level telescopes in investigating the far-off universe. These instruments give the fundamental capacities to notice the weak redshifted light from the earliest universes, permitting stargazers to reveal new insights regarding the universe's early stages. As JWST proceeds its main goal, it is normal to uncover much more about the epoch of reionization. Furthermore, the arrangement of the primary stars, worlds and dark openings resulting perceptions affirmed the presence of CS 1019. However, more definite data stayed tricky. The earliest light in the universe has moved such a long ways into the infrared piece of the range due to the universe's development that a strong, committed infrared instrument like JWST is important to test it. Actually, so when JWST went along CS 1019, the most brilliant of the Hubble systems from this epoch was a conspicuous objective. The telescope gazed at the world for just all 1 hour with its instruments, yet returned an abundance of information in that hour. It was similar to wow, check out all that we can see with JWST. We've seen this entire piece of the range of this cosmic system and any universes almost immediately in the universe we've never seen, said astrophysicist Rebecca Larson. I was just wrecked by how much data. However, at that point, something she wasn't exactly anticipating, that likewise should the illumination of star development there was a expansive emanation include ordinarily related with AG. When she referenced it to some AG specialists, things began to get fascinating. Ordinarily, a cosmic system with regards to the early universe transmits either light from an AG or light from star arrangement. To see both in a similar system was very startling. Sun said there is some effect that the dark opening is having on the outflow lines that we're seeing. However, the vast majority of what we find in our pictures is as yet overwhelmed by the star shaping piece of the cosmic system, that a super enormous dark opening existed more than 13.2 a long time back and was seen developing isn't quite as amazing as you could think. A lot bigger dark openings have been recognized in the early universe. Researchers actually don't have the foggiest idea how the dark openings in those universes became so huge that right off the bat in the universe. Presently, with the revelation of this dark opening just a short time later, the introduction of the universe, it is a secret in itself. The picture of the early universe is changing quicker than we expected, and like it or not, the time has come to return to the planning phase.
The discovery of CS 1019, one of the earliest and most distant galaxies observed, offers an invaluable glimpse into the early universe and the formation of its first galaxies. Despite its vast distance, CS 1019 shines brilliantly, making it an ideal target for further study. Galaxies like CS 109 stand out due to their high luminosity, meaning they emit more light than other galaxies from the same era. This brightness enables astronomers to scrutinize their properties in greater detail, even with the challenges posed by their immense distances and the redshift of their light. The identification of CS 1019 marked a significant milestone in observational cosmology, helping astronomers expand our understanding of the early universe. It revealed that galaxies had already formed and evolved extensively just a few 100 million years after the Big Bang. This finding underscored the potential of advanced telescopes like Hubble to explore the far reaches of the universe, paving the way for more precise observations with next-generation instruments like the James Webb Space Telescope JWST. While Hubble's capabilities confirmed the existence of galaxies like CS 1019, detailed analysis remained a challenge due to the extreme redshift of the earliest light in the universe. Only a powerful infrared telescope like JWST, designed to observe the infrared part of the spectrum, could effectively study these distant objects. Launched in December 2021, JWST was specifically engineered to probe the early universe during the era of reionization, when the first stars and galaxies were forming. Upon its mission, JWST quickly focused on CS1019, the brightest galaxy from this epoch, for just 1 hour. The data returned was rich and detailed, providing astronomers with invaluable information about the galaxy's composition, structure, and star-forming activity. These observations uncovered new insights into the development of CS1019 and similar early galaxies, offering clues about their growth and evolution in the context of the universe's infancy. One of the most surprising findings was the dual emission of both star formation light and a broad emission feature typically associated with active galactic nuclei, AGN. This dual emission is unusual for early galaxies, which usually emit light from either star formation or AGN activity, but not both simultaneously. The presence of both suggests that CS1019 hosts a massive black hole that is actively growing by accreting matter. This discovery has profound implications for our understanding of the early universe, challenging existing theories about the formation and growth of black holes and galaxies in the first few 100 million years. Moreover, the detailed study of CS1019 and similar galaxies provides critical information about the timeline of reionization. By analyzing the light from these galaxies, scientists can reconstruct the state of the intergalactic medium at different times and determine when and how reionization occurred. This data is essential for constructing a comprehensive picture of the early universe's history and the formation of its first structures. The discovery and subsequent study of CS1019 highlight the importance of advanced telescopes like JWST in probing the distant universe. These instruments are crucial for observing the faint, red-shifted light from the earliest galaxies, allowing astronomers to uncover new details about the universe's early stages. As JWST continues its mission, it is expected to reveal even more about the era of reionization and the formation of the first stars, galaxies, and black holes. Although Hubble confirmed the existence of CS1019, detailed analysis of the galaxy remained elusive until JWST's advanced infrared sensors captured a full spectrum, revealing a wealth of data about its composition and star-forming activities. This unprecedented level of detail has made astronomers realize the power of JWST's capabilities in studying the universe's earliest stages. When astronomer Rebecca Larson first encountered the vast amount of data from JWST, she was astounded by the level of detail. However, there was an unexpected finding: the presence of both star-forming light and AGN-related emission. After discussing this with AGN specialist, Larson and her colleagues were shocked. It was unusual to observe both types of emissions in the same galaxy from the early universe. The discovery points to the influence of a supermassive black hole on the galaxy's emission lines, though most of the observed light still comes from star formation. The existence of a supermassive black hole in CS1019, located more than 13.2 billion years ago, challenges our understanding of black hole formation. While much larger black holes have been detected in early galaxies, scientists remain puzzled as to how these enormous black holes formed so quickly after the Big Bang. The discovery of such a black hole in CS1019 adds a new layer of complexity to our understanding of early cosmic evolution. The rapidly changing picture of the early universe, revealed by JWST's findings, challenges our existing models and suggests that we may need to reconsider our assumptions. As JWST continues to gather data, it is expected to further transform our understanding of the universe's infancy, shedding light on the mysterious processes that shape the cosmos in its earliest moments.